Hello everyone, welcome. So we looked at how to calculate the expected value of a random variable. If you remember from our very first lecture of random variable, there we have looked at that for an experiment we can have many associated random variable, and also we looked at we can define a new random variable that can be a function of another random variable. So let's say we have a random variable x, and let's say we are defining a new random variable y that is a function of original random variable x, and now we are interested in finding the expected value of new random variable y. How we can do that? This is what we are going to learn in this video. So let me first of all give you a clarity about the question, and next we will see how we can proceed with the solution. Let's say you have or you are doing some experiment and it will have outcome, and let's say we have some random variable x, right? So outcome is getting mapped by this random variable x. Let's say we will have some outcome with some probabilities like 0.4. So this is first outcome, and we have another outcome that have the chance of occurrence with the probability 0.3, and we have another outcome that have chance of occurrence is 0.1, and we have another outcome that have chance of occurrence that is 0.1, and this is the associated random variable x for this experiment. So what is happening here, that this random variable x is mapping all these outcome to some real number. So let's say the random variable x is mapping this outcome to somewhere at place x5 on real number, and this outcome is getting mapped to somewhere at real number by this random variable x, and again this outcome is getting mapped to 3 by this random variable x, and this outcome is getting mapped to somewhere at 1. Now if I ask you what will be the expected value of this random variable x, you can make use of the definition of random variable definition of the expected value, and you can easily find that what will be the expected value of this random variable x. Now let's say we are defining a new random variable y, and this new random variable is a function of our original random variable that is x. So you carry out the experiment, there will be some outcome, and this outcome will get mapped by this random variable x to somewhere on the real line. Once you know what will be the value of x, you will put it here, and according to some function, that output will give you that what random variable y will take the value, right? So this random variable y is depending on what's the value that random variable x is taking. You carry out the experiment, you know the outcome, you know the x, you know the x, you know the y. So you carry out the experiment, and let's suppose you get this as an outcome, and this outcome will get mapped by this random variable x to some value 5. So random variable is taking the value that is 5, and once you will put here 5, then according to some function or mapping, you will get the output y. So this 5 is getting mapped to here y by this random variable y. Similarly, this 4 that random variable is taking the value is getting mapped to 4 by this random variable y, and so on for all other possibilities. Now we are interested in finding the expected value of this random variable y. How we can do that? We can make use of our definition for finding the expected value, and we can find the expected value of this random variable y. So we have this definition of calculating the expected value of a random variable. We can make use of this definition and we can find the expected value of this random variable y. But point to note here is that if you want to make this definition for the calculation of this random variable y, that is the function of this original random variable x, so in this case we are averaging over the values of y, right? So you should know that what random variable y is taking the values, all the values, and with what probabilities. So you should have an idea about, let's say this random variable is taking, y is taking the value 3, right? So y is taking the value 3 with the probability of what? So in this question or example, we have every point, so we can just look at what is the probability that random variable will take the value 3. Random variable y will take the value 3. So this 3 event is associated with the value that random variable x is taking 3 and 1, and it is associated with this event that have the probabilities 0.2 and 0.1. So random variable y will take the value 3 with the probabilities 0.2 plus 0.1. And another value that y can take is 4 with the probabilities 0.4 plus 0.3. So what we have done, we have make use of our formula of expectation and we have average over the values that random variable y can take. In this case, we should know that what y is taking, and also we should know what is their associated probabilities. Then we can make use of this formula. But let's suppose we do not have the info about the PMF of this random variable y, or maybe without calculating the PMF of random variable y, we can even also calculate the expected value of y. So y is a function of a random variable x, right? So we just want to calculate the expected value of this function, of this real function. Let's look at another way of finding this expectation of this y. So expected value of this random variable y. So let's call this alternative way, and it is the same, and you will see that. Let's first find out. So if you look at here, x is taking the value 1 10% of the time, right? And when x is 1, y is 3 with the probability 10%, that is 0.1. When x is taking the value 3 with the probability or 20% of the time, and when x is 3, y is 3. So basically what we are doing, we are doing the average over x, right? Let me do it first of all, then we will conclude, then you will have the good picture. So x is taking the value 3 with 0.2 probability, and whenever x is 3, then y is 3. So 3 with the probability 0.2. And what other value x can take? So other values that x can take is 4. So 30% of the time x is 4, and when x is 4, then y is 4. And what other value x is taking? X is taking 5. 40% of the time x is 5, and whenever x is 5, y is 4. So if you look at this value and this value, both is same. If you rearrange this, then you will get this one. But this way of calculating what we call is the expected value rule, right? If you look at here what we have done, so this is 3, right? And this is the output of this function, that is y. So whenever this value x is 1, y is 3. So we can write this one like g of 1. Yes, because g of 1 is 3. And similarly, whenever x is 3, y is 3, so we can write this 3 as g of 3. So whenever x is 3, y is 3 with the probability 0.2. And similarly we can write for other, that will be g of 4 and times 0.3 plus g of 5 times g 0.4, right? If we have to write this in general, so this is what the general form of this. So what we are doing here, we are carrying out the summation over the value of x. For each value of x, we calculate the corresponding value of y and we multiply the corresponding value, the corresponding probabilities. So this will give you the expected value of random variable y, and this random variable y is a function of the random variable x. And this is what we call the expected value rule. What's the benefit of doing or calculating the expected value of a function that is a... So let me repeat one more time. So what's the value of finding the expected value or finding the expected value using expected value rule is that we have another random variable that is the function of some original random variable. So in this case, if you look at the formula, we are running our summation over all the possible values of x times. So we just need to see that if x is taking this value, what will be the corresponding value of y, and we need to know the probability of these random variable x that is it is taking. So the point is that we do not need to know the probabilities of the random variable y that it is taking, right? That we have calculated in first way. In first way, if you look at, we are running the summation over the values of y, and here we need to know and we need to calculate the probabilities of random variable y that it is taking, right? But in expected value rule, we are running over the x random variable and we just need to know what is the corresponding value of y, and we just need to know that what's the, for what value of x there, what is the corresponding probabilities, and we sum over all those possible values. That will give you the expected value of random variable y. We will do more problem, and in next video we will look at one more properties of this expectation, and afterwards we will do few problems whatever we have gone through this expectation. That is all. Thank you.